Hey Bella, I didn't know that you're here today. Are you here doing the chemistry project too?
Yeah, are you?
Oh, I was just doing the thing too, yeah, just doing some sailing, some chemistry. You know, in everyday life, chemistry is just all around us, and I just think we don't take the time to really be thoughtful about ways it impacts us, especially as sailors. You know, these are our boats, and in sailing, the whole thing is to go fast, and even though a sailor can be, you know, mentally strong and physically in shape, you have to be thoughtful about your boat, and you can't win races without a fast boat. One of the greatest ways to have a fast boat is to have a clean boat. Now, these boats do have fiberglass hulls, and as much as we love them, they are vulnerable to bacteria called cyanobacteria, commonly known as algae. If you look at this beautiful lake, we have plenty of runoff from fertilizers such as nitrogen and whatnot that helps not only accelerate the growth, but also creates a lot of dirt and builds up on our boats. As you can see here, this kind of builds up, we're able to take off with forms of sulfuric acid and hydrochloric acid, muriatic acid. And what we're basically looking for is less resistance, less drag, meaning a faster boat. In a sense, if we want to talk about chemistry, we could say that a fast boat is kind of like a primary carbon, and a smooth, fast race would be like an SN2 reaction. Concerted, quick, and no resistance. Now, if we want to really get into detail, we're going to go shift it over to my friend Bella, and she's going to tell you all about the chemistry.
Hey Javi, what are you doing here?
You know, just some boats and chemistry.
Me too, what a coincidence. I was just going to go over the general mechanism for how acidic boat cleaners get rid of cyanobacteria on our boats. So, first, as you see, this is our general formula for our cyanobacteria, which has a nitrile group. And the first step of how the acid gets rid of it is protonation, which makes it easier for our nucleophile, which is the H2O, to attack this. Next, our oxygen is deprotonated. The one that came from the water is deprotonated, which leaves us with this. And then this nitrogen is also going to be deprotonated, which gets rid of this bond. As you see, it's here now. And now, in step 6, finally, our oxonium ion is deprotonated to reveal a carbonyl. And you can see there's a new pi bond that formed right there. Alright, so this is the general mechanism. It's obviously a much more complicated process, but the main takeaway point here is that our nitrile group is the key group in the bacteria that is causing damage to our boats and causing us to go slower. That's the part that we need to clean. So, yeah, basically the point here is that we're getting rid of this in order to make our bacteria less functional and our boats cleaner.
Thumbs up for Oh, go Knowles! Oh, now
Back
that
again.
We're at the end of this, and we have to say a couple words. Namely, thank you, Dan. We know we're not the best students. We try. Sometimes we're mad in class, but you try, and we're trying now. So thank you, Dan, from Bella and Javi.
Thank you.
See you guys.